So theano is a Python library for optimizing compiler for manipulating and evaluating mathematical expression, especially matrix valued ones. In theano, the computations are expressed using a numpy-esque syntax and compiled to run efficiently on either CPU or GPU architecture. So the final release as of today, that is November 2023, is 12th November, so it's pretty recent. It is primarily developed at the Montreal Institute of Learning Algorithm (MILA) at University of Montreal. The name of the software references the ancient philosopher Theano, long associated with the development of golden mean. Let's look at some sample code here. The original Theano examples defines a computational graph with two scalars a and b and a type double and an operation between them, addition, and that creates a Python function that does the actual computation. So we start by importing the theano library and particularly the tensor class. We will define a and b, the tensor.d scalar type, and then create a simple expression c a plus b, and this convert this expression into a callable object that takes a and b. For that we use f equal to theano.function, and that takes a and b, and then the parameter c. Then bind 1.5 to a and 2.5 to b and evaluate c. So we can find more details at the University of Montreal site. I'm not sure where it can be applicable, but nevertheless it's a good find. So yes, this is being referenced from numpy. NumPy obviously is the library in Python programming language. So particularly adding support for large multi-dimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. The predecessor of NumPy is numeric, which was originally created by Eugene Guingin and a contribution from several other developers in 2005. Travis Oliphant created the NumPy by incorporating features of the computing numberian into numeric, the extensive modifications. NumPy is an open source library and has many contributions. NumPy is a NumFocus fiscally sponsored project. The main features we can go through: the ND array data structure, examples, NumPy random dot import, the transpose with the metric operation, universal functions, linear algebra, tensors, incorporation into OpenCV, nearest neighbor search, F2Py, quickly wrap native code for faster scripts. We can continue our exploration to other topics such as array programming, list of numerical analysis software, matplotlib, row and column image router. It's a could be an interesting topic to explore. Row and column image router. In computing the raw major order or column major order, it's methods of storing multidimensional arrays in linear storage such as a random access memory. Difference between the orders lies to which element of the array are contiguous in memory. In raw major order, consecutive elements of a row reside next to each other, whereas the same holds true for consecutive elements for column in column major order. While the terms allude to the rows and columns of a two-dimensional array, that's matrix, the orders can be generalized to arrays of any dimension by noting that the terms row major and column major are equivalent to lexicographic and co-lexicographic orders, respectively. Data layout is critical for correctly passing arrays between programs written in different program, and it's also important the performance when traversing an array because modern CPU architectures processes sequential data more efficiently than non-sequential data. This is primarily due to CPU caching, which exploits spatial locality of reference. In addition, contiguous access makes it possible to use SAMD instructions that operate on vectors of data. Some media, such as magnetic tape storage, accessing sequentially in orders of magnitude faster than non-sequential access. We can stop our acceleration at this moment, and we can pick up other topics at a later time.